internal traffic between the DCs is growing faster rather than the traffic with the outside world. Therefore, and unfortunately, the solution which we have had before, they didn't allow us just to have the reliable traffic, also to provide the secured services. Until then, we had the RSVPTE, the choice for some vendors, but unfortunately, in the scale of the network which we have, this system responds very slowly on the problems, on the troubleshooting, and we needed some engineering methodology to be improved. How it is organized. That is the big picture. You should not be scared. Of course, I'm not going to speak about everything in every single detail, but I go step by step. That is our network design, how we started. We started with 3 data centers, 3 DCs, and we decided also to build up the second backbone. The Facebook engineers, they are sometimes called the switchers, but it was built on the routers. And this is the system which supports the BGP. In order to have the possibility just to renew it, to update it, also to provide the software, to develop it, etc., we had to put it in a parallel manner. Today we have the 8 parallel layers, and each of them can be, by the way, switched off from the exploitation. By one by one, according to the time, etc. Roughly speaking, just to add some routers, to renew, to update them, etc. Also, the internal, the itineraries, as well as the scales, to show which links are alive, what is the topology. We have some internal construction for the Facebook. In order to have some gradual the shifting to the backbone and not all of them to be switched on, and also to have the opportunity to have the good balancing between the layers, we had to develop the BGP, which is very important for the separate and single virtual machineries, and those itineraries are just built there using the different injectors, so-called injectors, and then they help us, those which are at the DCA, and they are used for those which will be used for the DCB. So we collect the information about the traffic which we have here and along the ways, and we communicate this information using controllers, because these controllers serve for the different pairs of the sites, as well as the MPLS maps, in order to have the different the traffics, in order not to overload our links, to make them enable to be operational. So we, by the way, can take it out here. Here can say the typology discovery, OpenR. As we have the full control on these protocols, it's a Facebook's routing protocol, allowing just to add some new features to the protocol. Again, it is about the traffic onboarding. We, of course, gradually tried to introduce the express backbone here, gradually, step by step, and the entire information, what we are trafficking there, what is the topology, what is the composition of the topology, they are generated here. In order to achieve the safe work of the injectors, because they are also doubled, by the way. They have the backups and they have some different lengths of the additional prefix. How this works, the traffic engineering? Of course, if we take the current situation, and this presentation is not first time displayed here, it is an updated version. Last year we had only one source for the information in that traffic, but now we already have the second source of the information. They are the meters on the rotors. So these are the meters which help us to switch the system to the next group. So we are doubling this information in order to be to the more safe side. So it puts together this traffic. It's the packages of 30,000. Then they go to the base. They are aggregated with the sites, with the pairs of the sites, and we have the special type of the service here. At every single router, we have the LSP agents running on the routers, and they can set up also the points as well as the measures on a router. So you can see it is not exchanged here. It is done by the controller. How the algorithm of the selection works, algorithms of also distribution of the parameters. So we have three sites here. And we try to send the 100 gigabit through using this particular system. But this 125, we divide into the portions, the 25 gigabit each of them, but in fact not so much, maybe some 16 or 17. And then each of these pieces, they are marked, and then gradually they select their 100 gigabit, and the remaining 25 are sent by using the another routers. We have also some additional flows of the data, but they will be allocated according to the ongoing locations. Also, in addition to the route, for the backup, we also have path allocation, the capacity constraint, the primary path, and here we find the shortest way. For each traffic class, we have 4 classes of traffic. We select the separate LSP. We just need to understand that the traffic between the data centers, as the route shows, they are quite different. Because we may have the traffic which we call the platinum, where we should not lose the packages, but there are also the traffic where the loss of the package is not so critical. Therefore, we need to use and apply different algorithms for the different classes of traffic. For platinum traffic, we are using the constraint, the passport, and I try to explain now. For the bronze, where we are not so much afraid to do something, we are using the different algorithms. We are balancing here the remaining capacity, and then we maximize all the ways according the links to make it minimum. So minimization of the mistakes, of the errors, provide us with the possibility just to keep the balance, strike the balance. And when we did it for the bronze one, we had some empty lines almost everywhere. Even the 100 gigabit spike traffic, even it is not important for the platinum, it still works. But we, by the way, lose very, very little there. Now about the driver. It is managed by the driver. It is one of the elements for the controller, and it works in a way as it is displayed on this particular slide. There's just only one thing. When we speak about the LSP, we have to underline here that it is the agent program LSPs. And it is a special protocol within of the backbone, and it is also the assumed, the topology is assumed by it, because if there is any interruption of the primary path from the general one, then LSP1 will be reconnected to the backup path. Therefore, if the backup path is disconnected, then if both are disconnected, we are losing the connection. If the backup connection is disconnected, but the major one works, then the LSP agent also automatically will be disconnected. I already said about the difference, what is the difference between the platinum and the bronze and silver, because the different algorithms are applied here for according to the location, according to the capacity of the traffic capacity, but we don't care about drops here. They try our best to reduce it. Now I would like to speak about the controllers, because when we have our own controller, we can manage and the algorithm for the traffic engineering. It is really very flexible approach, and we try to build up the system in a way to deploy it for the different equipment and devices. What lessons we have learned? First of all, it was about the software management. Lots of software components we face there, and in fact, we of course have some standards for the Facebook. We try to establish and deploy the proper chains, very flexible for updating and upgrading. When we speak about the manual upgrade, it is almost impossible, because we have the huge number of the devices as well as the system. Therefore, it is automatized. But with respect of the rebuild, it is when we are reconstructing the routers. Also, we have the automated validation about the network, whether they actually meet our expectations. So this automation provides with the possibility within the team just to check very quickly whether the system works, the network works. Maybe something is wrong, maybe something is broken. But at the same time, we have the global detector, the global detector to find some mistakes. It is also the special project. All the servers or the Facebook, they do it for each other and for one another. It's a full detection by NetRoad. So we have some internal, we also have some external, but they enable just to trace and do the same what is done by the tracer IT. But the design is slightly different. What we gain, what we won. First of all, it's an easy rollout of new software, the new features. Also, we can very rapidly just to remove the components from the network and not to wait until the LSP will be reorganized within the network. Also, we found that this construction can be connected to the backup ways within the parts of a second. It is almost physically very accessible minimum. They are maybe the hundredths part of the 100th part of seconds. Yeah, it's a round trip time. And also they can re-optimize the LSPM within 30 seconds during the controlling time. And also in a real time we can see what is going in the network. We also got the possibility to have some experiments with the traffic engineering, and we have also some parallels, and we can compare them. So this comparison of the outcomes are really very important. I mean the introduction of some new features between the layers because they are just similar. Yeah, it allows us to move faster. It was found very interesting, very interesting experience for the company. Now we put together all the data centers of the Facebook, and we are also going to do it for the further ones. So if you have any questions, you always can apply, not only now, afterwards, but also through the communication means, because we are growing company, so we need new engineers. Next question, how the mapping is organized? The flow or the, for instance, as far as I understand, you make the positive based routing. So who, where, when make the mapping? Currently, on the servers, we have the agents, the rolling, and they put the DCP, the signs on the traffic, depending on the type of the traffic. So on a server, we know what type of complexity we have there, especially for the softing. And the BPF is in the nuclear of it. It is marking entire traffic and gives the proper mark. Then it goes to the backbone router, and then it has the next hop group for each DCP at the mark, and it then identifies the itinerary, the routing. What else to connect there? As far as I understand, you don't use the channels, or maybe you have no problem with regard of the balancing. We have the aggregated interface, so-called the per channel, but any problem of balancing within it, we didn't see it. How you are going to achieve, for instance, 280 links aggregated, having the flow more or less equally distributed between those links? Between at that time, you have to play with the marks. And also, it is quite difficult to predict, make any prediction. Okay, what I see now and what I know now is that we cannot see here any problem. But it does not mean that the problems do not exist. That's what I can tell you now. The problem may exist, but I don't know about it. Konstantin Mikhail, you talked about the IPU. So your network, your internal network, the traffic goes to IPv6. Yeah, it is internally, the IP6. We have them only somewhere in some corners on the monitorings of the hardware, which cannot work with this. Therefore, so the vendors who do not support it, for instance, no, we are not going to buy anything from such vendors.